Hello, welcome to yet another episode on this YouTube channel. Today we are going to see how to manage Kubernetes secrets with Azure Key Vault. My name is Nilesh and I blog at handsonarchitect.com. I'm also active Microsoft Most Valuable Professional or MVP. So let's get started. In this video, we are going to use the same example which I've been using in my earlier recordings. This is about a RabbitMQ consumer. So we have a producer which is producing a set number of messages onto RabbitMQ, and then we have a consumer which acts as the consumer of this queue, and we have KEDA which does the auto scaling of these consumers based on the number of messages which needs to be processed. So we will extend this example today to see how we can integrate the Azure Key Vault or AKV to store secrets. So this is an example where we are currently storing some values as environment variables. We are passing these into the Kubernetes environments, and these are used by the consumer pod. So we have values like what is the environment, ASP.NET Core environment set as development. We have the RabbitMQ host name, we have the RabbitMQ username and the password and batch size. So if you look at all these values, these are stored in clear text, and this is not good for a production like scenario. So what we are going to do is follow the practice which is recommended by something like 12-factor app. As per this practice, what 12-factor app recommends is we should have all these secrets or the information which is like username, password to be stored in an external key vault or external vault, and we will use Azure Key Vault for storing this, all these the username, password and the RabbitMQ name. So we will store them as secrets. In terms of Kubernetes allows us two ways to store these kind of configuration information. The first one is the config maps, and the second one is Kubernetes secrets. So config map is environment specific configuration. So we can store environment specific configuration like what is the development environment or what is the environment name like development, UAT or SIT and production, and then all these name value pairs. That is good for storing plain text, but when we are dealing with secrets, it's better to encrypt these values. So even if somebody has access to these values, they can only get the encrypted value. They can't use a plain text value. So that is where Kubernetes secrets comes into the picture. That's another way in which we can pass values to the pods, and we are going to use this approach. We will encrypt or we will store all these values like the host name, the username, password and batch size as encrypted values in Azure Key Vault. So what are the prerequisites for running this demo? We need a Kubernetes version 1.16 or higher for running these particular steps or whatever I'm going to do. I will come to it later. Why do we need 1.16 or higher? We also need Azure Key Vault or AKV. In the interest of time, I have set up the instance of Azure Key Vault, and I've also set up Azure Container Registry. I will show you how this needs to be set up, and this can be done outside of this particular video. So let's get started and see how do we integrate Kubernetes secrets with Azure Key Vault. So what I've done here is I have gone ahead and deployed a Kubernetes cluster, and this is a 2-node cluster which I have created, and I'm running some prerequisites here, like for, as I said during the initial discussion, that we need RabbitMQ and we need KEDA. So I've gone ahead and deployed these prerequisites onto this cluster. So let me just say kubectl get nodes to verify how many nodes do we have. And as we can see here, we have got 2 nodes, and these are running on version 1.18.2. So the first thing that we need to do in order to deploy these AKV integration with the AKS cluster is to create a Azure Key Vault. So here I have a script which does this creation of the Key Vault, and I have already gone ahead and executed this particular script. So what the script does is it takes in some parameters like the subscription name, what is the resource group name for Key Vault, what is the resource group location, what should be the name for the Key Vault, and it also needs a cluster name and the resource group name for the AKS cluster. And as part of the initial setup or bootstrap, what we do is we check if the resource group exists. If it doesn't exist, then it will create a resource group. Same way, it will check if the Key Vault exists, and if it doesn't exist, it will go ahead and create the Key Vault. So let's just go into the portal and look at these Key Vault details. So if I log in into the Azure portal using my credentials, and if I go into the ngAKV, that's the name of my Key Vault. This is the Key Vault which allows us. Key Vault is a service which is provided by Microsoft Azure, and it allows us to store keys, secrets, and certificates. And it also allows us to define access policies as to who can access these keys, secrets, and certificates. So what I have done as of now is gone ahead and created 4 secrets which are required for my consumer. So I've created the batch size, RabbitMQ host name, RabbitMQ password, and RabbitMQ username as the secrets. And if I look at the versions, we can see that these are stored using this secret identifier. Each of these secret has a secret identifier, and I can see what is the secret value. Okay, so all these have been set up as part of the secrets. And once we have these secrets or keys or certificates, we can define who can access these secrets. So right now you can see that since I'm the administrator of this particular subscription, I have access to this Key Vault, and there are different management operations that I can do with the Key Vault. Like I can do get, list, update, create, import, delete. All these kind of operations are supported for my user. In terms of the keys. In terms of the secrets, I can do similar things like get the secret, list secrets, set values for the secret, delete, recover. And if we go at the certificate level, again, there are different sets of permissions which can be enabled for the user. So once we have these, so if we go back to the script, we are doing things like after the Kubernetes, after the AKV or Key Vault is created, we are retrieving some existing values and we are giving the permission. So this is required because when we created the AKS cluster, so let me go back to the initialize AKS cluster script here and see how did we create the cluster. So in the cluster creation, let me just zoom this in. Okay, if we see here AKS create, we are creating a cluster with managed identity and we are attaching the container registry to that. So I've also created AZACR container registry and attached that container registry at the time of creation of the cluster itself. So this container registry will store the images for my producer and the consumer. And since we are enabling the managed identity, the worker nodes which are created as part of this, they will be the ones who will be requesting these, they will be the ones who will be pulling these pods or pulling these images from the container registry. So I need to give the permission to those particular managed identities to be able to pull the secrets. So what I'm doing here is I go into the AKS cluster. This is the agent pool which has the identity assigned to it, and I get the existing identity, and from that existing identity I get the ID, client ID, and I assign the secret permission to get. So this will allow me to use that managed identity to pull the secret from Key Vault. It will have the permission only to pull the secrets as a result of executing this command. That's the part which is related to accessing the keys from Key Vault. The other thing we need to do is we need to create some custom resource definitions. So let's go back onto the browser and we see how do we create those custom resource definitions. In order to connect our Kubernetes cluster to the Key Vault, what we need is something called as Kubernetes Secret Store Driver or CSI driver. This allows us to mount multiple secrets, keys, or certificates stored in an enterprise grade external secret store into the pods as a volume. So the external secret store that we are using currently is the Azure Key Vault or AKV. And if we look at the container storage interface, the definition of this is it's a standard for exposing the arbitrary blocks of file storage systems to a containerized workload on the orchestration system like Kubernetes. So this is a pretty standard mechanism which allows different vendors to create the file system onto the Kubernetes cluster, and it implements a standard interface which allows the Key Vault to which allows these providers to extract secrets and mount them as volumes. So that is what we are going to do as part of this exercise. One thing that we need for creating this driver, Kubernetes Secret Store CSI driver, and the specific implementation of that with the Azure is it's called as the Azure Key Vault Provider. So it takes some parameters which are specific to the Azure Key Vault Provider. One of them is the tenant ID. And we can get the tenant ID by going into our Active Directory. And if we look at the default directory, we have the tenant ID stored here. We can also do this in a scripted manner. And if we go up here, in this script, I was extracting the tenant ID. This can be done by using this AZ account show command, and by converting it into a JSON. And if we get the tenant ID property, we will get the same value. So the way we set up this is we create what is called as, let me just scroll up here. So in my Kubernetes manifest files, I have a folder for AKV, and we need to create something called as secret provider class. This class or this kind of object is a custom resource definition. This is created with the kind of secret provider class, and the API for this is Secret Store CSI v1 alpha 1 version. So we need to deploy this particular custom resource definition first, and this is done using the Helm. So I'll be using Helm chart to deploy this. So I have a PowerShell script which is called deploy CSI AKV provider. Let's go ahead and deploy this. And while this is getting deployed, it's pretty fast in fact. So we can see here that it has added CSI Secret Store Provider Azure, and it has deployed this as a Helm chart. So if I do kubectl get crd, we should have the custom resource definition for Secret Store. So you can see that Secret Provider classes Secret Store custom resource definition has been added. And if we look at the pods which are created, we should see some additional pods in our cluster now. So we see that there are different pods created as part of this custom resource definition and the installation of the Azure Provider for CSI. So there are these CSI Provider Secret Store driver as well as the provider pods which are running in the cluster. Now once we have this installed on our cluster, we need to create a object, or we need to provide the information how the object should be fetched, or how the secrets should be fetched from the key vault, and that is done using this file. So here we create a object of type secret provider class. We give the name as Azure Key Vault or Azure KV name, and I will come to this. The provider is Azure here. I'll come to the secret objects a little bit later. The parameter it takes is whether we should use pod identity. So in this case, we are not going to use the pod identity. We are going to use a managed VM identity. So this is what I mentioned earlier, that since we are creating a AKS cluster by using managed identities, we set this parameter to use the managed identity. And then we need a user assigned managed identity. So this is the identity which is associated with that managed identity. The ID of that identity, we need to provide it as the value. Now to get this ID, I will run initialize AKV, which will give me that ID, the managed identity ID. And as part of this PowerShell script, it will also assign the read permission or get permission on the key vault for that managed identity. So while the script is running, let's go and check on the key vault. So now we see that currently there is my user or my name, and there are 6 other identities which are having the access allocated or assigned to this particular key vault. After we finish this script, we should have one more access added in this. So these were some of the other clusters which I had created, and they have these IDs which are assigned. We should see our currently running clusters managed identity added into this access policy shortly. So it's now going and retrieving the existing Azure identity or the managed identity which is assigned to my Kubernetes cluster as a result of creating that AKS cluster using use managed identities. So this is the client ID which we need to assign to our parameter here. And once we have assigned the once we have set the value for user assigned identity ID, we need to provide what is the key vault name and what are the objects. So objects are the array which we need to pull from that particular key vault. So here we are specifying all those 4 objects which I have currently parked in my key vault: the batch size, RabbitMQ password, username, and host name. And I need to specify what is the type of the object. Since I have put all these as secrets, I have specified object type as secret, but if I put it as a key in the key vault, this would be a key, or if it's a certificate, then the value here would be a cert for object type. And object alias is the alias that we want to give to this particular key or the secret that we are pulling from key vault. So since the script has executed now, let's go back and check that we have the access granted. So we should see an additional value here in the access policies. So we can see here, this is AKSMQ cluster agent pool. So this is the managed identity of my current AKS cluster which I'm running, and you can see here that it has only the get permission for the secret. And this is because in my script initialize AKV, if I go down, I'm giving only the permission to get. As a result of this statement, you can see here that secret permissions I have given only get permission to that client ID, and that is how I am restricting the access to this key vault. So now we have the access part set up. So my Kubernetes cluster or the node pool using this ID will be able to query the secrets which are stored in the key vault. Now once those key vault secrets are available as these objects in my class here in the secret provider class, I am syncing them, or I want to sync them with the Kubernetes secret object. So that is where secret objects come into the picture, and we say the provider is Azure. These are the secret objects we want, and the secret name for that particular secret objects is AKV secrets. So the result of this is, or the intention of doing this is, I want to create a Kubernetes secret named AKV secrets of type opaque, and I want to map these objects as keys. So the key here is RabbitMQ hostname, and I want the object name as RabbitMQ hostname. So this is what is the object name which will be exposed as a secret name or as a data in this AKV secret, and the key for that is RabbitMQ hostname, and this key is what we specify as the alias here, object alias. So I'm exposing all these four as Kubernetes secret values. Now once we have this Kubernetes secret values or Kubernetes secret created, the next step is to go and use it in our pod. So let me go and apply this particular class which will create the secret provider in our Kubernetes cluster. So for that I need to navigate to the Kubernetes manifest files AKV, and I run the kubectl apply command, and it will create the secret provider class with the name as Azure KV name. With that created, let's go and use this in our pod or in our deployment. So to use it in our deployment, I will go and update the consumer deployment. Consumer is the one who is going to use those secret. So the first thing we do is mount that as a volume, and this is done using a CSI driver. So we use the secret store CSI driver, and this name matches what is the name of our CSI, the secret provider class. So if we look at this Azure KV name, this is exactly same as what we provide in the metadata here, Azure KV. So what we are saying here is the secrets would be mounted as volume in a volume named secret store inline using the CSI driver, and the provider for that is Azure KV name. Once we have the volume mounted or volume created, we link it with the Kubernetes pod by using volume mounts, and we mount it inside the pod in a folder or at a mount path MNT secret store. And the last step of this is in the pod spec or spec for this deployment, the environment variables, we change the way they are fetched or they are set. So we have the name RabbitMQ host name as the environment variable name, and we are reading the value for this from a secret. The name of that secret is AKV secrets. So this value is matching what we specified as the secret name, and then the key is the key that we specified here. So that way we link the secret to a particular value inside that secret. So if you have used Kubernetes secrets in the past, this would typically be the data element. So the name of the secret and the data element of that particular secret. So one secret in Kubernetes can have multiple data points or data, and each of that data will have a key. And that is what we are using here. So in our case, we have one Kubernetes secret named AKV secrets, and that has got 4 keys. And as a result of that, or we are inferring all those 4 keys using this value from secret key ref construct in the Kubernetes manifest. So once we have all these settings in place, we are good to deploy our application on the Kubernetes cluster. So to deploy the application, I have another PowerShell script, which you might remember if you have seen my earlier videos. This is called deploy tech talks AKS. This goes and deploys all the producer and the consumer manifest. So now we have the producer and the consumer deployed. Let's go and also deploy the KEDA autoscaler. So this is the autoscaler, which will automatically scale the number of instances of the consumer. And if we now go back and to get pods, we should see the pods running. For all our application specific objects. So we have the two producers running, or 2 instances of the producer pod running. We should also have a consumer. So in order to have the consumer, let's try once again. We don't have the consumer running at the moment. This is because the KEDA autoscaler, it checks if there are any messages to be processed, and if there are no messages to be processed, it will scale down the consumer. So in order to have the consumer, we need to pump in some messages, and to get those messages, let's go on to Octant, and in the services, let's get the IP, using which we can go and populate the messages onto our RabbitMQ. So I'm using Postman here, and I'm generating a set of, let's say, 5,000 messages instead of 500. Let's populate 5,000 messages onto our RabbitMQ. And since we got the status as 200 OK, that means those messages were populated. Now if we go back to our RabbitMQ UI, we have the port forwarding done, which will allow us to connect to the RabbitMQ UI and see this in action. So we will use the user and the password to connect to RabbitMQ, and we see that there are 5,000 messages which are ready to be consumed, and we should see the consumers coming in shortly. So the KEDA should scale the number of consumers. We can watch it here. We don't have any consumers at the moment. Let me just go back and for a moment tear down the tech talks and redeploy it once again. So I'm just redeploying the tech talks. So the consumer and producer have been deployed again now, and yes, so we can see that the consumer has started scaling. And if we go back onto the RabbitMQ UI, we should see that there are 3 consumers which are up and running, and this will start increasing until it hits the limit of 30. So I think the autoscaler at the moment, as per the configuration, what we have is 30 as the scaled. The maximum replicas is 30, so we should see here that once it reaches 30, it will stop scaling anymore. It will stabilize at 30 consumers, and all these messages will be consumed. But that's not the point here. So the idea of all this was to show how we can pull the secrets from Azure Key Vault, AKV, into the secret object of Kubernetes, and then mount those secrets into the pod, and then use these. Let me just close this pop-up. Okay, so use the secrets into the environment variables. So we have gone through that process. Now let's go back to the presentation and see what did we do during this demo. So we started with the provider, Azure Key Vault provider for secret store CSI driver. If you remember, initially I said that we need 1.16 version of Kubernetes or higher, because if we are using 1.15 or below, the approach to link the Key Vault is slightly different. There is a concept called Key Vault Flex Volume, which is deprecated. So if we are using 1.15 version of Kubernetes, we still need to use this Flex Volume based approach. With 1.16 and higher, we use the secret store CSI driver. There are some capabilities which this driver provides in terms of mounting secret keys certificates onto the pod starting at the time of starting the pod using a CSI volume. It supports mounting multiple secret objects into a single volume. It supports security features like pod identities. It also creates a portability with secret class provider or secret provider class, a custom resource definition. One good feature is that this also supports Windows containers, and this needs 1.18 and higher version of Kubernetes. What we also saw is the support for syncing of Kubernetes secrets. So we pulled the secret from the Key Vault and we synced them with the Kubernetes secret objects. And it also supports multiple secret store providers. So in our case, we were using the Azure Key Vault provider. There is also support for HashiCorp Key Vault. So if we want, we could use more than one Key Vault provider or more than one provider for secret stores. So there could be a situation where some of the secrets are stored in Azure Key Vault and some other secrets are stored in something like HashiCorp Key Vault. And we could use 2 different providers in the same cluster using this CSI provider. In order to install the CSI driver, we used Helm, and we used a Kubernetes cluster with 1.18.2 version. In my case, I was using Helm 3.2.4. In order to add this CSI driver to my cluster, I have to add the repo, which is, I'm referring to it directly from the GitHub URL. So what you can see on the screen is the GitHub URL to that repo. Then we do a Helm repo update and we run the Helm install command. CSI Azure driver is the name of my install, and this is the chart from where I'm going to deploy that. Once I have deployed the CSI driver, I create a secret provider class. And this is a custom resource definition, which is using a Kubernetes or Azure Key Vault specific parameters to store secrets in the CSI driver. In case of Azure Key Vault, there are 4 different modes which can be used to connect to the Key Vault. First one is based on the service principal. Next one is based on the pod identity. Third one is based on VMSS, which is virtual machine scale set, user assigned managed identity. And the last one is virtual machine scale set, system assigned managed identity. And this is the approach that we use during this demo. If we are using this approach, we set properties like use VM managed identity as true. We provide the user assigned identity. This is the managed identity client ID. We provide the Key Vault name, and we provide the tenant ID. So based on these 4 properties, our CSI provider is able to pull the secrets from Key Vault. And we also went ahead and synced those secrets from the Key Vault onto a Kubernetes Secret object. Once we have the Kubernetes Secret object synced, we also provided the Key Vault a permission. So we enabled the access policy to read secrets for the managed identity. And beforehand, I had populated the Key Vault secret. This can be done using a portal, where you can go into Azure portal, go into the resource, which is Key Vault, and add secrets, or we can also use API. So with this regards, I have again a small script which I can show you quickly. If I go into my PowerShell scripts, there is a script called deploy AKV secrets. So this is the API based approach, where I'm using the Azure Key Vault or AZCLI command line interface to set the secrets. So I can uncomment these secrets and uncomment all these lines and populate these values. So this is how I had initially populated. So you can use a similar approach as well if you want to use a programmatic way of creating the secrets using AZCLI or other supported APIs. So once we have the secrets populated, we update the Kubernetes deployment file, and the pod spec or the deployment spec has been updated to have the AKV secret mounted as a volume mount. And then we also updated the environment variables to pull the values from Kubernetes secrets. So if we look at the complete picture, this is how it looks like. We have the TechTalks consumer, which is the object, or which is the Kubernetes manifest or Kubernetes object, which is going to use the Key Vault secret. The pod of that, which is getting created as part of the deployment, it uses a secret which is named as AKV secrets, and that secret is mounted using Azure KV name, which is populated using the AKV or Azure Provider, which is the custom resource definition we deployed using Helm. And this is populated using the managed identity by connecting to the Key Vault. So that is how it works end to end. So the 5-step process to do this is, in the step 1, we deployed the CSI driver. We used Helm for deploying this. Next step is the Key Vault. So we grant the read permission or get permission for the secret part only. And we also populate the AKV secrets here. Then on the Kubernetes side, we create a secret provider class with AKV Provider. And we also sync the Kubernetes secrets with the AKV values. Next step is we update our manifest files, and we mount the volume using CSI driver, and we retrieve environment variables from the Kubernetes secret. And finally, we deploy the application to the cluster. So we can also verify this using Octant. So Octant is a UI which is allowing us to visualize the state of the Kubernetes cluster. And here, if we go to the workload section and we go to the pods. I hope one of the consumer pod is still running. No. So since all the messages have been consumed, the KEDA autoscaler has gone ahead and it has deleted or scaled down all those consumer pods. So let's go and recreate some pods by sending 500 messages, and that should trigger auto scaling again, and we should see some consumer pods getting created. The reason I want to show this is there is a very nice feature in Octant which allows us to visualize. So if I go back here, pods, and we should see in few seconds a consumer pods coming up here. There is a slight delay of about 1 minute when the polling happens to see if the consumers have to be scaled up as part of KEDA auto scaling. So until that scale in or scale up kicks in, we will not see any new pods. So we'll have to just be a little bit patient here. So what I want to show is if we go into the details of the pod or any object, Octant has this resource viewer which shows for a particular resource what are all the links, and the thing that I wanted to show is for the consumer pod that secret reference. So let's go back, pods, we should see the consumer coming in. I'm not sure why the consumer is not kicking in. Usually it kicks in within few seconds. The postman was 200. That means the messages got delivered. If we go to RabbitMQ, yes, we do have 500 messages here. Something is wrong with the consumer today. It's not automatically kicking in. So the other way I can do is I can again try just tear down and redeploy the application. Usually this doesn't happen. Looks like something is wrong, but again we are able to see the core concepts related to this demo, so I'm not going to worry too much about that. So let me quickly redeploy the application and hopefully we'll be able to see consumers coming in. So currently it's deleting the producer and the consumer. These have been deleted, so let me go and redeploy the application containers. So this has been deployed now, and yes, so we can see the consumer is up and running. So if we go back to the Octant now, in the Octant UI we should see some consumers, and if I click on any of the consumer here, let's go into the resource view, and here we can see that the RabbitMQ consumer deployment pod, we have the AKV Secret. That is what is mounted as a secret onto this pod. Let's look at the one which is running. These are getting deleted for some reason. So we had some messages which were picked up, but also some pods which got terminated. So let's go back to the Octant and see what happened there. We don't have any consumers running at the moment. Anyway, never mind. So in the short span of time, we were still able to see that the secret has been mounted onto the consumer. So we also saw that we can enhance the application security by using the enterprise grade key vault. What I mean by that is we have different levels of access. At the key vault level, we can control using access policies to limit what kind of user or which users have access to the keys at what level. So do they have get level access? Do they have update, delete kind of access? So we can have a very granular level of access using access policies for all the secrets or all the keys as well as certificates stored in the key vault. We also use the managed identities with virtual machine scale sets for our AKS cluster, and we were able to sync the secrets between the key vault and the Kubernetes secrets. So the source code for this whole demo is available in the feature AKV integration branch for my PD TechFest 2019 repository. It's on GitHub. You can rerun the whole demo if you wish to follow the steps. All the scripts, PowerShell scripts, and the steps are mentioned in the README file. With that, I conclude this demo. In case you want to connect with me on any of the social media platforms, these are the different links that I have, or these are the different platforms I use, and I'm available on these. My first name and last name is quite unique, so on most of these platforms, if you search for Nilesh Gule, you should be easily able to find me. So thank you very much. Use this as an opportunity to learn something new, code with passion, and strive for excellence. That's the motto I live with, and I hope this session was useful for you to understand some of the concepts related to how we can integrate Azure Key Vault AKV with Azure Kubernetes Service AKS. With that, I conclude this demo. Thank you for watching. If you find this useful, please like and also share this with your friends. Don't forget to subscribe to my channel as well. Thank you once again.